All right, this is a video on that will be covering question number 9 on the test review 4B. Okay, it's a little word problem that deals with quadratics, right? So let me read the information. An object is launched directly upward at 64 feet per second from a platform 80 feet high. An equation to model the height h at time t is given by h equals negative 16t squared plus 96t plus 40. All right, so before we do anything, let's actually draw a picture that will represent that information. All right, here's my ground. All right, I have a rocket is being launched from a platform, put right here, that's 80 feet high. So this right here is 80 feet high off the ground. So it's 80 feet off the ground. So this rocket launches, hits its maximum height, and it comes down and then crashes into the ground. Okay, let me zoom out a little. All right, so what we want to find, right, and this curve, this quadratic, is represented by the formula h equals negative 16t squared plus 96t plus 40, right? And we're used in terms of x and y, so let me put that in something that is familiar. In other words, it's like saying this, 96x plus 40, all right? They're just using different variables. They're trying to use variables that represent information, like h will represent the height, t represents time, in this case it's seconds, okay? So this curve is represented by this equation. So the first question it asks is, when will it attain this height? When, keyword is when. In other words, how long will it take? Will it take, well, it is the object or that's being launched. How long will this object take to reach the maximum height? That's what it's asking. In other words, here's the maximum height. That's the vertex. We call it the vertex. Remember, vertex is either a max or a min, right? So in other words, we're trying to find the vertex. Now, this right here is in terms of x, y, but if I write it back to in terms of what the variables that they use, it will be t and h. All right. So we want to know when. So that means we want to know what t is or what x is. You know, how many seconds does it reach to get from here to here? In other words, they're asking how long will it take from here, from when it's launched. Let's see, go down. How long will it take from here to here? How long? All right. So we're finding the vertex. So we have to find the vertex. So we are given a quadratic. So to find a vertex given the quadratic in standard form, we got to use the negative b over 2a method. All right. So let me just put right here. So we're going to do negative b over 2a. Now if we go back, we know that a is negative 16, b is 96, c is 40. So negative b, so it'll become negative 96 over 2 times negative 16. All right. So using the calculator, you're going to get negative 96 over 16 times 2 is negative 32. So now 96 divided by 32 gives me a positive 3. So it takes 3 seconds. All right. In other words, this point here, the x-coordinate, is 3 seconds. So it takes 3 seconds. All right, now we want to find what will be the object's maximum height. In other words, if I know what the x-coordinate is, they want to know what's the y-coordinate. So I got to take 3 and I got to plug it back into this equation. All right, so I'm going to do negative 16 times 3 squared plus 96 times 3 plus 40. Just use a calculator. I'm going to put in the calculator just the way it looks. So I'm going to do negative 16 parenthesis 3 parenthesis squared plus 96 parenthesis 3 parenthesis plus 40. All right, so there, I don't know if you can see it. There you go. It's in the calculator, just the way it appears. Hit enter, and it's the maximum 184 feet. So my maximum height that this object reaches is 184 feet. All right. So just finding the vertex, you find A and B, parts A and part B. Part C, how long will it take for the object to hit the ground? In other words, what they're asking, if I take this equation, set it equal to 0, solve for x. All right, so let's use the quadratic formula. Since we already know what A, B, and C is, and we've been using the quadratic formula, so I'm just going to plug it in. So it'll be negative 96 plus or minus B squared, 96 squared, minus 4 times A times C, all over 2 times A. Okay. So let's see what that equals. So this will be negative 96 plus or minus all over negative 32. Let's do the radical here. That's not, sorry folks, that's not picking up too well. There we go. All right, so let's do 96. I'm going to put it just the way it looks. 96 squared minus 4 parenthesis negative 16 parenthesis parenthesis 40 parenthesis. Just the way it looks. All right, hit enter and we get 1177.6. So then we can put this to the other side and we'll finish it up. So we have negative 96 plus or minus the square root of 11776 all over negative 32. All right, since this is a large number, I'm going to see if it's a perfect square. So I'm just going to do second square root 11776. No, it's not a perfect square. Now, it's all right. We don't have to simplify it because if we read the question, how long will it take? I want to know in seconds. How long will it take for my object to hit the ground? In other words, I want to know what this x-coordinate is. Right? In other words, we know it takes, what, 8? What do we say? It takes us 3 seconds from here to here. How long will it take from here to here? All right? Now, if you notice, using the quadratic formula, we got large numbers, and we got to use a calculator, and so forth. There's actually a shortcut. All right? Some of you guys probably saw it already, or even thought it. We know from here to here is 3 seconds. Remember the vertex? This is the axis of symmetry, and the axis of symmetry cuts the graph in half. So if half of it is 3 seconds, that means the other part should be close to 3 seconds, right? So it should be almost, this should be around 3 seconds more. Okay? Well, let's just double check. So what I'm going to do, I'm going to use a calculator, and I'm just going to put this value in, just the way it looks. Okay? So I'm going to do negative 96 plus second square root of 11776 parenthesis. All right, hit enter, and I'm going to divide by negative 32, and I get a negative answer. Now, negative answer, that means can someone did it take the rocket a negative 0.4 seconds? Well, in time cannot be negative, so therefore can't get that answer. So now we go back and do negative 96 minus the square root of 11776. Divide that by negative 32, and we get approximately 6.4 seconds. So it takes 6.4 seconds to hit the ground. All right. And that should make sense because look here, we started up here. We didn't start down here with the lock. We started at 80 feet high, so it took away some of the distance. So we know from here to here is 3 seconds. Well, halfway, so in other words,
attention, the 3 o'clock buses will be arriving momentarily. The 3 o'clock buses will be arriving momentarily.
so that means from here to here is 3 seconds, but so I still got a little bit more time involved. All right, so we knew it was going to be around 6 seconds. So, but more accurate, it is 6.4 seconds.